We hear so many big promises, don't we? Especially about energy, about the future. But how much do we really know about the detailed plans behind them? Think back to, say, 1931, Winston Churchill. He predicted nuclear energy would bring advances incomparably greater than the steam engine. Bold stuff. And then just 20 years later, Calder Hall, the world's first commercial plant, started construction right here in the UK. There's this huge optimism, cheaper, cleaner energy. But, well, despite that start and maybe a bit of a comeback in the 70s, things changed. Public opinion shifted, investment dried up, and the UK sort of fell behind.
Yeah, and that history, that context leads us perfectly into what we're looking at today. It's the UK government's Civil Nuclear Roadmap to 2050. And it really is comprehensive. It's not just wishful thinking. It lays out the strategy, the steps for the UK to, well, try and become a leader in nuclear energy again.
Right. So our mission here for you listening is to really dig into this roadmap, pull out the key bits. We want you to come away understanding what the UK is planning, why they're doing it, the how behind this big nuclear push, and maybe uncover a few surprising things too. Okay then, let's get into it. Why now? After all this time, why is the UK suddenly, reviving its nuclear industry in such a big way? What's the main driver?
It is a pretty significant turnaround. If you think back, the 90s, nuclear was about 27% of UK electricity.
Yeah.
Today, it's down to around 15%. That's only about 6 gigawatts of capacity. And that really flies in the face of how nuclear is seen now as, well, the roadmap calls it, the only current form of reliable, secure, low-carbon electricity which can be deployed at scale.
So reliable, secure, low carbon. That sounds like it ticks a lot of boxes. What are the really big drivers mentioned in the roadmap for doing this now?
There are two main things really pulling in the same direction. First, definitely net zero. Getting to net zero emissions by 2050. Nuclear provides that consistent zero-carbon power, baseload power. And second, crucially, energy security. The roadmap is pretty blunt, mentioning avoiding dependence on, and I quote, the likes of Putin again. It links it directly to vulnerabilities from imported gas, geopolitical shocks, like the invasion of Ukraine. So domestic energy is key.
Wow. Okay, so net zero and security. The ambition then, you said 6 gigawatts now. What's the target?
The target is big. Up to 24 gigawatts of nuclear capacity by 2050. That's potentially enough to cover maybe a quarter of the UK's entire projected electricity demand. And it's not just the UK thinking this way. They've joined over 20 other countries, the US, France, Ghana, UAE, places like that, endorsing this net zero nuclear declaration, which calls for tripling global nuclear energy by 2050. So this kind of global momentum building.
A quarter of demand from 24 gigawatts. And something else the roadmap points out, which often gets missed, is efficiency, land efficiency.
Oh, absolutely. It's quite remarkable, actually. Nuclear power is typically something like 30 to 40 times more land efficient than a solar farm with the same output.
30 to 40 times. That's huge, especially in a crowded country like the UK.
Exactly. And this roadmap, it looks beyond just electricity for the grid. That's what's really interesting. It talks about other opportunities, using nuclear heat for hydrogen production, for example. That hydrogen could power industry, maybe even vehicles down the line, or using the direct heat from reactors for homes or industrial processes, a massive source of emissions currently. And then there's the medical side, producing isotopes for diagnosing and treating diseases like cancer. It shows nuclear's potential is, well, broader than we might think.
Okay, so we get the why, net zero, security, efficiency, even these other applications. But the big question is how? How do you actually go from 6 gigawatts to 24? What are the concrete steps the project's happening now?
Right, the how. Well, the foundations are being laid. You've got current projects under development. Hinkley Point C HBC is the big one. First new nuclear station in, well, a generation. It got consent back in 2013. Construction started in 2016. It's aiming for 3.2 gigawatts, running for about 60 years. And the economic impact is pretty significant already. Over 60% of contracts to UK firms, billions spent in the Southwest. Over 1,000 apprentices trained, surpassing their target, actually. They've hit some big milestones, too, like delivering the main reactor vessel, lifting the huge steel dome onto the reactor building. It's physically taking shape.
Okay, so Hinkley Point C is underway. What else is in the immediate pipeline?
Then there's Sizewell C, or SDC. The plan is for it to be basically a replica of Hinkley Point C. Same design, 2 EPR reactors, another 3.2 gigawatts. The government stepped in as a shareholder in late 2022, putting in about $700 million initially, now committed to $1.2 billion total. And replicating HPC is key here. The idea is to learn lessons, improve efficiency, and hopefully bring costs down by basically building the same thing twice.
Right, learning by doing. essentially. Okay, so those are the big conventional projects. But you mentioned innovation earlier. Is that where things get, well, really different?
Yeah, this is where the strategy diversifies. Large-scale reactors like Hinkley and Sizewell are still seen as the backbone. They've been the workhorse since the 50s. And the roadmap even mentions exploring another large-scale project after Sizewell C. But a huge focus now is on new tech. Firstly, small modular reactors, SMRs.
SMRs, we hear that term a lot. What exactly are they in simple terms?
Think of a standard nuclear reactor, but smaller, less than 500 megawatts usually. They use tech that's mostly known and proven, but the big innovation is how they're built. The idea is modular manufacturing, building components, even whole sections, in a factory, then shipping them to site for assembly, like advanced construction kits. Great British Nuclear GBN is running a competition right now to choose which SMR designs the UK will back. They're aiming for a final investment decision by 2029, with power coming online maybe mid-2030s. And the goal isn't just one or two, it's deploying fleets of these SMRs. That's how you potentially get major cost reductions and build up UK manufacturing.
Fleets of SMRs. Factory-built reactors.
Okay.
And beyond SMRs, you mentioned another.
Yes. Looking even further out, there are advanced modular reactors, or AMRs. These are genuinely next generation. They use different fuels, different coolants, allowing them to reach much higher temperatures. We're talking 500, maybe up to 900 degrees Celsius. That high-grade heat is what you need for things like making steel or cement without fossil fuels, or producing hydrogen really efficiently. So the UK wants to get a demonstration high-temperature gas reactor, an HTGR, built and running sometime in the 2030s to prove the technology. Okay, so large reactors, SMRs, AMRs, it's a multi-pronged approach.
Yeah.
How do they plan to keep this momentum going? What's the sort of rhythm of development? The roadmap sets out a kind of drumbeat. The commitment is to secure investment decisions for roughly 3 to 7 gigawatts of new nuclear every 5 years, starting in 2030, running through to 2044. That's the planned pathway to hit the 24 gigawatts by 2050. And interestingly, the long-term view is that government involvement should actually lessen over time. As the market matures, the private sector is expected to take more of the lead in funding and delivering projects.
That's a huge amount of activity to coordinate, 3 to 7 gigawatts every 5 years. How is the government actually setting itself up to manage all this? You mentioned Great British Nuclear, GBN.
Exactly. GBN was set up pretty quickly, spring 2023. It's designed to be the government's dedicated delivery body for new nuclear. Its first job is that SMR competition we talked about. But its role is meant to grow, covering other nuclear programs, advising the government on how to unblock investment hurdles, that sort of thing. It's meant to be the engine driving this.
Okay, GBN is the engine. What about where these things will actually be built? Siting. Are we talking just existing nuclear sites, or are new areas on the table?
This is a really interesting shift in policy. Historically, there was a defined list of suitable sites. Now, for developments beyond 2025, they're moving to a more flexible, criteria-based approach. Basically, if a site meets the criteria technical, environmental, safety, it could potentially host a new nuclear facility. And crucially, these projects get critical national priority status in the planning system. That should speed things up. The Nuclear Decommissioning Authority, the NDA, will also regularly highlight land it owns that could be reused. So yes, while existing sites are obviously still very important, this opens the door to potentially new locations, although community agreement is stressed as being vital.
Critical national priority. That sounds like it's aimed at cutting through red tape. What else is being done to streamline things like regulation without obviously compromising safety? That's always the balancing act.
It absolutely is. And the UK regulators, the Office for Nuclear Regulation, ONR, and the Environment Agency, EA, are internationally respected. Safety is paramount. But they are looking at streamlining. One big area is the Generic Design Assessment, the GDA, which approves reactor designs. They're exploring ways to potentially cut those timescales by up to half. A key part of that is making better use of assessments already done by regulators in other trusted countries. If a design is approved there, maybe the UK process can be faster. There are also wider planning reforms for big infrastructure projects, these NSIPs, including a new fast-track option. And environmental assessments are changing too, moving towards environmental outcomes reports, EORs, which are meant to be more focused and efficient. Plus, they're literally asking the industry, tell us where we can cut bureaucracy safely. A smarter regulation challenge.
Okay, faster approvals, smarter regulation, but let's talk money. These projects are incredibly expensive up front. How does the roadmap suggest they'll actually be financed? This has always been a massive hurdle for nuclear.
A huge hurdle, yes. The roadmap highlights two main funding models that are available. First, contracts for different CFDs. That's what was used for Hinkley Point C. Essentially, the government guarantees a fixed price for the electricity the plant generates once it's running. For HPC, it's £92.50 per megawatt hour for 35 years. It gives investors long-term certainty on their revenue.
Right, so that helps once it's built. What about the massive cost during construction?
That's where the second model comes in, the regulated asset base, or RAB model. This is being used for Sizewell C. Think of it more like funding a water pipe or an electricity grid. Investors start getting a small, regulated return on their money during the construction phase, not just when it starts generating power years later. This shares the construction risk between the investors, consumers through bills, and the government. The big hope is that by reducing the risk for investors early on, it significantly lowers the cost of finance, which can be, a massive chunk of the total project cost. It could offer better value for money overall.
So CFDs for revenue certainty, RAB for construction funding, any other financial bits and pieces?
Yeah, a couple other things. The UK wants to join an international agreement, the Convention on Supplementary Compensation for Nuclear Damage, CSC. This basically strengthens the insurance and liability regime, giving investors more protection against, extremely unlikely major accidents. And also, there's a push to get nuclear included in the UK's green taxonomy. That's basically a list of what counts as a green investment. Getting nuclear on that list could unlock more private investment, maybe from funds focused on sustainable projects.
Okay, that covers the reactors and the money. What about the fuel? You can't have reactors without fuel. Any innovations there?
Absolutely vital. And the UK does have significant existing expertise here. Places like Capenhurst for enrichment, Springfields for actually making the fuel assemblies. The roadmap commits to regenerating and expanding these capabilities, building up that domestic fuel cycle again.
And there's the elephant in the room, Russian fuel. What's the plan, given everything?
Yeah, the roadmap addresses that directly. A clear commitment to end all reliance on Russian fuel and uranium supply by 2030. Full stop. And it's not just the UK acting alone. They're working with international partners, the US, Canada, France, Japan, the Sapporo 5 group. They've collectively pledged something like $4.2 billion to invest in building secure, alternative supply chains completely independent of Russia.
Right, diversifying away from Russia. And looking ahead, there's this next-generation fuel mentioned, HLEU, high-assay low-enriched uranium. Why is that important?
HLEU is crucial for many of those advanced modular reactor designs we talked about. They need fuel that's enriched to a higher level than current reactors use. The problem. Currently, Russia is basically the only commercial supplier of HLEU globally. So to avoid swapping one dependency for another, the UK is investing heavily up to $300 million a day in a domestic HLEU program. The aim is to have UK-based capability for HA enrichment and processing by the end of this decade. Urenco at Capenhurst is central to this. There's also another 10 million pounds from the Nuclear Fuel Fund going into related projects. It's about securing the fuel for the future reactors.
Fascinating. Securing future fuel. Now, you hinted earlier that nuclear isn't just about power stations anymore. What about things like health or even space?
Yes. This is where some really cutting-edge stuff is happening. On the health side, the UK actually imports most of the medical radioisotopes used in scans and treatments. So there's a program, the Medical Radionuclide Innovation Program, MRIP, trying to build up a domestic supply chain. And there's an amazing example. The National Nuclear Laboratory, NNL, has figured out how to extract a specific isotope, lead-212, from nuclear waste material at Sellafield. This lead-212 is used in something called targeted alpha therapy, TAT, which is a really promising new way to treat cancer. So we could end up with a sovereign supply, potentially treating thousands of patients a year, created from processing nuclear legacy materials. It's quite incredible.
Wow, treating cancer with isotopes from nuclear waste. And space. You mentioned space.
Yeah, this is pretty cool too. Another isotope, americium-241, AM-241, is being harvested from separated plutonium stored at Sellafield. And this British AM-241 is slated to power the main radioisotope power source, basically a nuclear battery for European Space Agency missions to the moon in the early 2030s. That would be the first time a British-made radioisotope actually powers a spacecraft system like that. And Rolls-Royce is even researching a tiny nuclear microreactor specifically designed, believe it or not, to potentially power a future moon base, aiming for 2029.
A nuclear reactor on the moon. Okay, bringing it back down to Earth slightly, what about the end-of-life stuff? Decommissioning old plants, managing the waste, that's always a big public concern.
A very valid concern, and the roadmap addresses it directly. For all these new stations, there's a decommissioning by design approach. That means planning for how to safely dismantle the plant and manage the waste is built into the design right from the very beginning. For the most radioactive waste, the long-term plan remains a geological disposal facility, a GDF. This is essentially a highly engineered vault deep underground, maybe 200 to 1,000 meters down, designed to contain the waste safely for millennia. And the plan is to size this GDF to accommodate all the waste from this future 24-gigawatt fleet. It's important to remember, though, the first waste from these new plants won't likely need disposal until the 2050s at the earliest. Until then, interim storage on site is considered very safe. And one other point the roadmap makes explicit: no plans for industrial-scale reprocessing of spent fuel from these new reactors.
Right, so planning for the end from the beginning. Okay, we've covered the tech, the funding, the fuel, the future applications, the waste. What about the people? Building all this needs a massive workforce. Where are all these engineers, technicians, construction workers going to come from? That sounds like a huge challenge in itself.
It is arguably one of the biggest challenges highlighted. The numbers are quite stark. The sector employed around 83,000 people in 2023. To hit that 24-gigawatt scenario, they estimate needing between 150,000 and 180,000 people by 2043. That's basically doubling the workforce. And there are other factors. About 10% of the current workforce is nearing retirement age, 60 plus. And there's a well-known gender imbalance, only about 21% women currently, though there is a target to get that up to 40% by 2030.
Doubling the workforce, an aging population, diversity targets. What's being done to actually build that pipeline of skilled people?
There are quite a few initiatives underway. You've got strategic bodies like the Nuclear Skills Task Force, NSTF, and the Employer-Led Nuclear Skills Strategy Group, NSSG, try to map out the needs. There are specific training programs like the Nuclear Graduate Scheme run by Energus, which has a really high success rate, 98% go into nuclear careers. And look at Hinkley Point C again. EDS investment there has trained over 1,100 apprentices already. They've set up centers of excellence for specific skills like welding and electrical work, and groups like Women in Nuclear UK, WIN UK, are actively working on improving that gender balance and diversity across the board. It's a multifaceted effort.
Okay, so a big focus on skills. And finally, what about the supply chain? The companies that will actually build the components, provide the services. Is the UK industrial base ready for this?
The roadmap argues that the UK already has a strong nuclear industrial base with a good global reputation. There are efforts to get the civil and defense nuclear supply chains working more closely together, finding efficiencies. The Department for Business and Trade, DBT, is focused on bringing in investment and also helping UK firms export nuclear goods and services. There's even international collaboration, like the Long Ops project with Japan, developing robotics for decommissioning skills that are valuable globally. And advanced manufacturing is key. The Nuclear Advanced Manufacturing Research Center, Nuclear AMRC, at Sheffield University is doing amazing work. They've developed things like electron beam welding that can apparently weld a section of an SMR pressure vessel in 1 hour instead of maybe 60 hours conventionally. Huge savings in time, cost, and emissions. And programs like Fit for Nuclear, F4N, help UK companies get ready to bid for nuclear contracts. It's credited with helping firms win over £2 billion in work and supporting thousands of jobs.
Wow. Okay, so when you pull it all together, the scale of the ambition, 24 gigawatts, the different technologies, large reactors, SMRs, AMRs, the funding models, the fuel strategy, the workforce development, the supply chain, this civil nuclear roadmap really is incredibly comprehensive. It feels like much more than just building power plants. It's about, well, rebuilding an entire industrial capability, isn't it? And
Right.
securing energy for decades.
It is, and the roadmap itself acknowledges this isn't set in stone. It mentions flexibility, the need to adapt to future uncertainties, constantly checking if it still represents good value for money. The ultimate goal isn't just 2050, it's sustaining nuclear power beyond that. And as we mentioned, the expectation is that government's role, while crucial now to kickstart things, will hopefully reduce over time as the private sector gains confidence and takes more of the lead.
So that vision Churchill had back in 1931, it was bold, but the path wasn't smooth. The UK journey with nuclear has been, well, complicated. With this new roadmap, this detailed plan, maybe this generation, maybe your generation, is the one that finally figures out how to unlock that potential he saw. Think about how it could touch your life-reliable energy, yes, but also maybe new jobs, new industries, even breakthroughs in medicine or enabling us to explore space. It's definitely something to watch. And the roadmap promises an update by the end of 2025, so we should get even more detail as this huge undertaking unfolds. Keep an eye on it.